Okay, hi guys. So in this lecture, we'll be continuing on seeing some more examples of addition polymerization reactions. So okay, let's get started. So another example is, suppose we have this compound. Okay, and we are passing this compound in first presence of R2O2 H nu. We get product A, which is a polymer. Okay, and then we are passing O3 zinc over the reaction mixture, so we get some products. So you have to identify what is product A and what are the products A. So obviously polymer A would be something like, we will be getting something like this: CH2, CH3, CH3, CH2. Okay, and then when we pass O3, so obviously one of the products which we will be getting is um, the reaction mixture on passing the O3 would be getting ozone coming into the picture here and here. So what will we be getting? We'll be getting something like CH double bond O, CH3. Okay, not H, plus 2 moles of HCHO. Okay, so again we'll be getting this, and obviously the polymer also you can break it. So from the chain we'll be getting many moles of this. Okay, so this is, in fact, this will be found in bulk, and this would be rare. Why rare? Because this, some of in the reaction mixture, some of this compound will also be found out. It will also be the O3 and zinc will also find some of these products as well. Some of the reactants molecules will also be present, and some polymer molecules will also be present. Okay, next question is, from product A, on passing O3 you are getting this product. Okay, plus 2 moles of HCHO, and when you react it with R2O2 H nu, you get polymers. Okay, so what is product A? So obviously product A is, at this is the CHO which is formed. Okay, so now what will happen is, here is, we will join these two on both the sides, so we'll be getting double bond C H2. Similarly we'll be getting here double bond CH2. Okay, and product B would be nothing but, obviously you can have a polymer of it, and we'll have something like N. Okay, so this is product B. Okay, next question is, so which of the following monomers can undergo cationic, anionic and free radical polymerism? So which of the following compounds can undergo cationic, anionic and free radical polymerization? Okay, so we have option A as this, B as this, C as this, and finally D as all. Okay, so can this undergo? So let's suppose we have a free radical here, then obviously, so, or let's say we have a electrophile which is attached here, then as a result positive charge will come on this carbon atom, and as a result, so let me draw it. So for the cationic part, let's see the stability of this cation. Okay, electrophile gets attached here. Okay, and then we have this will jump over to this, and as a result we'll be getting this compound N plus. So obviously N plus will be less stable, hence it will not go cationic. Similarly, in this case again it will not happen. Even if the substitution happens in this case of Cl atom, then partial positive charge will come on this atom, which gives rise to highly unstable vinyl cation. Okay, and in this case on this carbon atom, positive, negative and free radical all are stable due to plus M effect of, or minus M effect in case of minus charge on this carbon atom, all will be stable, hence this will be the answer. Okay, now let's see some more examples. Okay, so we have isopropene, or sorry, not isopropene, isoprene. So what happens in this reaction is we have isoprene here. Okay, and what happens here is when RO dot actually attacks on this carbon atom, what happens is it takes back the bond electrons and becomes a free radical here, and at the same time these two carbon atoms will form double bond here, and as a result we'll be getting something like CH3 and also this bond will be broken up to give rise to CH dot here. Okay, so as a result we'll be getting something like CH3, this CH3 comes here, then this CH2 H CH2 and again CH2 and another molecule here. Okay, this is n times. Okay, so this is cis product and it is natural rubber. Okay, now let's see another example wherein we have something like this. This is known as chloropropene, or chloroprene, sorry, not propene, chloroprene, and this undergoes this reaction. Okay, which is neoprene. Okay, and this is synthetic rubber. Okay, now let's move on to another concept, which is Lassaian test. So Lassaian test is basically for testing organic compounds having nitrogen, sulfur and halogen atoms. Organic compounds for testing N, S and X. Okay, so organic compounds having nitrogen, sulfur and halogen can be tested by this test. Just writing a note here that organic compounds having nitrogen, sulfur and halogen can be detected by this test. Can be detected by this test. Okay, now Let's say we have nitrogen plus organic sample. Okay, and if we pass on heat onto it, and if we get Na plus Cl minus, then if we pass it with AgNO3, if it precipitates, then chlorine is checked. And again sodium plus same sample, pass on heat, if we get Na2S, which can be detected by passing lead acetate. If black color PPT forms, then sulfur is confirmed. Again, if we have sodium plus organic sample, if we heat it, if we get Na plus Cn minus, then nitrogen is confirmed. Next, the question is, which of the following compounds will give? Which compounds give negative Lassane test? Okay, so the options are: first, this compound; second, we have something like 2,4-dinitrophenylhydrazine DNP; C, we have something like urea; and D, we have RNH2. Okay, so obviously it is an organic compound containing nitrogen, it is an organic compound containing nitrogen. I hope you remember the formula of urea. Again, this is a NO2 groups can be found at ortho and para positions. Okay, and is this an organic compound? No. First thing to be noticed for having a Lassane test is it should be a organic compound, but it is not an organic compound, hence A is the answer. Okay, now let us discuss some more questions on the same. So suppose we have something like CH3CO or COCS3, and we are passing it in presence of SCO2, then what will we be getting formed? So we'll be having something like C double bond O H plus selenium plus H2O. Okay, we won't be getting something like this or a acid, and also we won't be getting a alcohol. We will be getting something as aldehyde and only aldehyde. Okay, next example we have, again when we pass aldehyde in presence of SCO2, what would be formed? We'll be getting, again this CH3 would be getting converted into aldehyde. Okay, next if we pass this compound CH3 here, pass in presence of SCO2, then oxidation of this carbon atom will take place, in which will be getting ketones formed at both the positions. At this was already there, and this position will also be formed, forming a double bond between carbon atom and the oxygen atom. This is the alpha carbon atom. Okay, next let's discuss the last example, where we have something like CH3 C double bond O CH2 and we pass again SCO2, and we'll be getting oxidation of this carbon atom, and as a result we'll be getting something like 2 keto groups in the compound. One was already there and another formed due to presence of or passing SCO2 as the reagent. So with this is CH3. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing hydrate formation. Okay, till then, good luck and goodbye.